Okay, my name, can you guys hear me okay? Okay, my name is Ezequiel Golub. I'll be giving the talk about Ansible and Terraform. I was actually happy with the first talk that I forgot her name at the start of the PyCon, because she talked a lot about the human part of DevOps and this maybe new way of trying to bring together the teams. So very good. I'm going to do the technical part of two tools we use for doing that. So well, my name is Ezequiel Golub. I'm from Buenos Aires, Argentina. I'm very far away from my house right now. I'm super thankful for the PyCon Sweden organization for having selected me here and invited me here to come. I have been working in Python, mostly backend work, for the last 5 years, and for the last 2 years I have been working for a company called Whale Rock in the United States that does high traffic sites like the Kardashian Sisters, Howard Stern, and other big sites. So we have a dedicated ops/DevOps team. We build a lot of our own tools, and we try to use the best of the tools available, because the problem or the characteristic we have in this company is that we make one site, then replicate it for 5 sisters, or I don't know. Howard Stern has most of the site is the same as Kim Kardashian, or so. I mean, we build a lot of code to help us with that. So first question is, why should you complicate yourself? I mean, we all know how to SSH into a server, git pull, and touch a few buttons through SSH, then you get a new release. So why should you guys invest your time in this? Well, basically the list of benefits, it's pretty much similar to what, can someone tell me her name? Sorry. Emily, thank you so much. Okay, it's very similar to what Emily said, okay? It's breaking down silos, it's sharing knowledge and best practices between the ops and the DevOps team. It's trying to get continuous delivery going. One of the side benefits of this is that you tend to have better telemetry. When you're releasing every day, you are getting bugs pushed to production. Hopefully not every day, but every week. So you need to have better instrumentation in place to help you find those and before your client does. It enables to treat infrastructure just as another piece of code. So you get the same benefits of version control, pull requests, code review that you have for a normal software project. You can get that in your infrastructure. And you can duplicate, modify, try new things on your infrastructure without having to do a lengthy process and understanding better the consequences. And that allows you to start treating your servers as cattle, as in, this one is not working okay, I will kill this one and bring up a new one. That is okay. That is not, I will not say the best practice, but it's an accepted practice, because you have so much code around your servers that basically every server is expendable. I mean, you can kill any server and the service will self-heal and move on. So we will talk about two tools. The first is Terraform. When you hear Terraform, just think hardware. It's the server part of the process. It's bringing up new servers, new network, load balancers, whatever your cloud provider provides you. Terraform most likely has a library to interface with it. I know it works very well with AWS, and it kind of keeps up with the new releases. Sometimes it takes 2 weeks or even a month for a new feature to trickle down into the Terraform library. But I mean, what is working is working. I mean, you don't get a situation where something stopped working. And Ansible is for provisioning the server itself. So setting up Nginx, user accounts, Wizgy, whatever. I mean, Redis, whatever you need to put in there, you do it through Ansible. So some facts about Terraform. It's a fairly new tool. I mean, there are other tools in the market that do similar stuff, but we like it very much because of one of the features I'll say. The next slide. It has a pretty good release rate. It is open source. It is not in Python. Sorry. It's backed by HashiCorp, which does build a lot of DevOps or tools. I think the most familiar one is Vagrant, which was something that everybody used before we started using Docker. And they have Packer and a whole list of other tools. And all of them are pretty much good quality. I mean, you don't get like weird bugs using those. But the problem, as I said before, is that sometimes it can have a problem when the cloud provider changes something. So for example, I know AWS, we had a problem with AWS releasing something related to application load balancers. So they had a new feature, we wanted to use it, and it wasn't on Terraform, or it was, but it wasn't widely supported, or whatever. We waited 3 weeks, and I mean, the pull request got through, and then it was fixed. So what are the key features? Well, the one we like the most is that it's readable. Most of the other tools we have to do that, you cannot do this. I mean, you cannot like read the code and get a quick idea of what it's doing. We use CloudFormation for some stuff, and I mean, this will be like fill up the whole page. It has a very good engine to figure out the execution plan. So what it does is when you change something in your code, let's say you change the instance type, it will figure out what the change is. It will present it to you along with all the other changes it will do. It will give you like a summary of all the changes. And then you can decide if you want to apply that change set or not. So you take a lot of the guesswork of what would this code do in my cloud infrastructure. It takes it away. I mean, you always know what it's going to do. And the other thing it does with the execution plan is that it's pretty smart about parallelizing stuff and figure out dependencies. Like, I don't know, in AWS you have instance profile that you need to create before creating the actual EC2 instance. Well, it is smart enough to know that it will need to create that profile before creating the EC2 instance, on most cases. Sometimes it breaks and you need to like point it in the right direction. So it gives you the summary of the changes. It's pretty smart about doing it in a good order. It can show you a resource graph, like a nice graph about your infrastructure, which is nice. I haven't used it, but it's nice. It works with most cloud providers. I mean, I know that AWS support is very good, but it also supports DigitalOcean, it supports Rackspace. Thank you, OpenStack. I think Microsoft is paying money to get Azure into that list. But basically, I mean, it supports most of the big cloud providers. Well, sorry. And what it does, well, great. So it supports saving the state of your infrastructure to a remote location supporting logging. So you can get two teams or two people working on the same piece of infrastructure and not having like everybody step over everybody's change. So it supports saving that state on remotely, and it supports like logging out people while the change is being made. Basically, the two commands you need to know about Terraform are two. Terraform plan, which the output is what you see there. I mean, it will just tell you, well, I'm going to create a new AWS instance. I will not change anything, and I will not destroy anything. And when you're happy with the change, you go to Terraform apply, and it applies the change, and you can see it in your AWS console. So Ansible. It's a lot more mature. It's not as new as Terraform. It's also open source. It is on Python. It's backed by Red Hat. I think they bought it like 2 years ago. The good part of it is that it's agentless. You don't need to have anything running on your server to use Ansible other than SSH. So it's pretty lightweight, and you don't get the problem with having agents inside each machine. And it has like 450 modules. I mean, it can do like, you can actually do provisioning. You can do like, bring up EC2 servers if you wanted with Ansible. So how does it work? It SSH into each server and runs commands. That's it. There's no magic. You can actually see the SSH commands if you go down enough in the debug level. And the control node is just a computer that has SSH connection to your servers. I mean, it could be my laptop, or it could be like a server in your cloud infrastructure. The way Ansible decides what change it will apply is through the inventory and through the playbook. So what are those? Let's start with the playbook. It's YAML. It's pure YAML, no weird extensions on anything. The idea is that you describe the desired state of your server in that YAML file. It supports conditionals and loops. So you can do like when it's I don't know, when it's Ubuntu, you do one thing, but if it's Debian, no, Debian is the same. Sorry, Amazon Linux, which has all the other libraries, you do other stuff. It supports loops, so you can get a list and like start installing the libraries, and you have a big list of libraries, and it will just go over each one. It's pretty human readable compared to the alternatives, at least. And it supports error handling. I mean, it's pretty smart. You can say, well, if it fails, it will always stop and give you a nice way to find out why it failed, or you can have it ignore errors. I mean, it's pretty smart about it. So one part is the playbook, which is, again, the idea is that it describes the state. The other part is the inventory, which says basically what are your servers. I mean, who are they? At the end of the day, it's just a list of servers that you can group into whatever groups you want. So in this example, you're looking at a static inventory, which I just said, what is host 1, host 2, host 3, yeah, and host 3. There's an Atlanta group and a Raleigh group, and you have that group by region. So the Southeast has just Atlanta and Raleigh. Then if you're in the Southeast, you can apply some specific variables that Ansible will pick up and you can use on your playbook. And you can actually define like a bigger group, which is just the USA. So that's a static group, but the idea in the static group is the same as the dynamic inventory. Static inventory is the same as the dynamic. The difference is the dynamic goes to your cloud provider to get your server list. So at the start of each run, it will go to AWS and it will pull all your servers, make a list of them, and you can then use those. What is pretty smart is about caching, so you can define how much time you want it cached. So, I mean, if you have like 500 servers, it will take a while, but hopefully you have it cached and you will not like run that part every time you run Ansible. It supports AWS and other cloud providers with pretty good support, and it's pretty customizable. I mean, if you have like some specific way you want to address your servers, you can do that. I mean, the standard way is just by the tags on EC2, but if you want it by server name, you can do that. If you want to build groups with whatever logic you build your servers, you can also do that. Okay, well, let's do a demo. I hope the internet gods are with me on this. Not so far. Okay, so the letter is so small, right? So, okay, let's start with Ansible. No, let's start with Terraform. Let's start with Terraform here. Okay, this repository you're seeing, let me enlarge that a little bit. Oh, that's better. Okay, so this example is pushed to GitHub, and I think the link is on the end of this presentation. So, so basically, here we are looking at the EC2 console. I just killed the old server, so it brings it up from scratch. So nothing there. And let's see the code for this. This is like a basic Django app. Does nothing, it just returns an HTTP response, but it has WSGI and Nginx and all the stuff you kind of need to have it working. So let me enlarge this one too. So basically, this is a Terraform file. It's like the basic version of what you would need. You start by defining how it will call AWS. So it defines the region, it defines a profile, which is a way to have like multiple AWS accounts in your computer. It defines a VPC, which is the networking part. Then it defines how that VPC will access the internet. It creates a subnet for your instances to be created in. Then it creates the security group with just basic rules. I mean, it will allow SSH and HTTP to get inside the instance, and it will allow the instance to send packages to wherever. It defines the AWS key pair, which is the way you say what SSH key you will use. So, I mean, so you can actually SSH into your instance. It finds the policy, and the policy is the way that an instance has access to the resources of the rest of AWS. So if you don't define anything, the instance cannot do anything. It cannot like go to S3 and download stuff, push logs, push metrics, I don't know, talk to DynamoDB, talk to Lambda, all of that. So you need to actually like define what it's going to do. So what I'm doing here is that I created a small S3 bucket with the releases of this software. So we'll pull the releases from there and update. Well, this is more like, okay, it says who can assume what role and it's necessary. Here I define where the instance role, where the instance profile will have that web role that we just defined, and I define the instance type, AMI, and all the rest of the stuff. So, and here I define the S3 bucket. Oh. So this is like a basic like single server setup, the most simple I could find. So what you do is, I don't remember. I have the command right here. So basically what I tell this is that they will use a key name of PyCon Sweden for this. This is the EC2 keeper. And this is where it will find my public SSH keys. So it's checking it. I mean, I just deleted just the EC2 instance, so it will just create that. But it's checking everything. It's checking well, that went too fast. It's checking the IAM role, keeper, IAM instant, S3 bucket, VPC. It's checking everything if it's the same, and if it's the same as its internal ID it maintains. Well, the AWS ID, not internal. And then it will try to create it. I should have done the plan first, but plan it will just say this and that it will create it. That's it. It just created a server. And let's show you Ansible one. And that is deploy. Yeah. So this is the same. I mean, here we have a playbook, and what it does first, it defines what are the hosts it will actually try to set up. In this case, it's the ones that are tagged with the name web server, but I mean, there are better ways to do that, but sorry, I was rushing. It will create a deploy user, it will install Nginx, it will create the configuration. Here, it will copy it from files that it has in the same folder. It will restart Nginx every time that config change. That's what that notified restart Nginx means. And it will create these two files, Nginx and WSG params. This is an example of looping, actually. I mean, I'm doing the same stuff with two different files. Install WSG. It will go to S3 and get the latest release. It will clear out the old files and download the file, create clear out the temporary directory, and it will move the new release to its location, which is home deploy Django. Then it will create the virtual M if it needs to. There's a lot of bash here, which seems like not so elegant, but it's the one-liner way of doing it. I mean, you can do the same with maybe 3 tasks using Ansible, but sometimes it's just easier to put a little bit of bash there. It's saying that it will become the user deploy. By default, it will be using the, I think, the root user. Install the WSG packages. Here I'm cheating because I'm not shipping the dependencies of the Django with Django itself. So I'm just putting it there so it works. What else? Generate the INI file, empty the directory, move it to its final location, sets the correct permission, and then it will restart Nginx and restart WSG if you ask for it. These handlers part are only called when someone notifies it. So how does that work? Let me get my cheat sheet again. Okay, this usually takes a minute. So while that is going on, I will quickly talk about how it's built in the real usage. You don't get like one YAML file for your Ansible, and it's like 5,000 lines long. You have a way to split the file and the functionality into modules, which are called roles in Ansible. Usually have like multiple playbooks, and the modules/roles are pretty well thought out. It's the same for Terraform. You usually do modules for example, I mean, how you build a web server with all of its IAM profiles and I don't know, load balancers and stuff. You put it in a module, then you reuse it for every environment. And let's see if this finished. It's not finished. Okay, we're cutting it pretty close. Well, internet is not helping me, but oh, there it is. So basically, it's going over each task. It's saying it's figuring out if it's something changed or not. Because if it changed, it can notify. If it hasn't changed, it will not notify. And it will basically throw out like a big list of stuff it's doing. So I think we have like 5 more minutes. So maybe we want to go to questions right now, and you can look at this while you do questions. Yeah, sure.
What is the reason to use Terraform? Can you not use Ansible in
The question was why use Terraform and not use Ansible for all. The implementation of Terraform, the execution plan, and all of that, basically is the killer feature for us. I mean, because in Ansible you don't have a way to like try what the changes would be. I mean, you can either do them or not. So Terraform has that, and for us it was like the killer feature. Plus, I think the way they represent the feature, the resources is a better way than what Ansible does for server resources, not for software. Sorry.
I wondered how easy is it to change or modify your Ansible configuration, for example, and then to redeploy?
Well, change small stuff is super easy. I mean, like add a library and all of that, it's like really easy. It worked. Awesome. Like changing a library or like simple stuff, it's pretty good. Awesome. So, but when you need to build like a module, like a complex mechanism, like behavior, it takes a while. It's not like you do it in 5 minutes. So this demo, I made it mostly from scratch, and it took me like 4 or 5 hours, and I had a lot of reference material to go to. So it's not like you do it in pretty quick. But once you have it, you build upon it. I mean, you don't need to do like the whole thing at once. You can still have like manual processes or anything. Sorry, that.
So we use Ansible quite a lot.
So we use Ansible quite a lot, but from different developers' computers. And I was wondering, how do you approach logging when it comes to doing these sort of fairly important infrastructure changes?
Well, the best way we found, which I don't know if it's the good way, but it's the one that works for us, is we have a list of users, and we apply their SSH keys to the servers that they should have access to, and that way they get SSH access to those servers. So, for example, I know you can give SSH access to the development servers to all your developers, but maybe a small subset will get SSH access to that.
Yeah, sorry, I didn't phrase my question correctly. So you did your playbook here.
Yeah.
Now, what if you close that tab and I want to look at what did you do yesterday?
If I close my tab, well, if I was working correctly, I will have pushed that code into a PR before doing that.
Yeah, sure, but how do you monitor and log the changes you can?
Well, you have the code for that. I mean, you have the code you build, I mean, the YAML you build, that's the source of truth for your infrastructure. I mean, you have to be very careful and not be sloppy with it, but if you commit to it, you get like the advantage of just looking at a PR or change set and you know what changed. I mean, it's okay? You okay? Oh.
Yeah, I had a microphone.
Oh, sorry. Sorry, didn't see you.
I think this is going to be the last question. Sorry, we're going to...
I'll be at the lobby afterwards. So.
Okay, thank you. So with everything you showed, you can write all your infrastructure as code.
Yeah.
But so what would be the process? Like, you make a pull request because you want to make a change to infrastructure. What do you do in this pull request? Can you test it, for example?
Yeah, but no. So, I mean, there's no like unit test or automated test on this. I mean, you have to trust the knowledge of the people doing it. I mean, because I mean, most of the problems with infrastructure change come from unforeseen consequences. Like, okay, let's change instance type to save $50 a month, and your instance starts running out of memory. So you really rely on the like collective knowledge of your peers to know that sort of situations. I don't know if that answers your question. Sorry.
Thank you.
Okay, thank you so much.